Special angles examples. So we saw two special triangles and how to work in degrees and radians for them. For degrees, we can still use regular technique and calculator can still give us 60 degrees, 45 degrees or 60 degrees as one of our reference angles. But when we work in radian mode, calculator will not help us. So we'll need to remember how to solve them using those two special triangles. So let's see some examples here. It says find the theta in exact form where theta is between 0 to 2 pi such that sine theta equals half. So let's quickly decide which quadrants this happens in. That will be our first step. Sine positive. So that will be in quadrant 1 and 2. So we'll say quadrant 1 and quadrant 2. Now we are given half and we want answer in exact form. So we have to realize that this is a special triangle. Another way to remember that is if you see numbers like 1, 2, square root of 3 and 2. Combination of those, again 1, 2, square root of 2 or square root of 3, it is most likely a special triangle. So let's quickly remind ourselves of a special triangle with half in it. So that will be something like this triangle with pi over 6 and pi over 3. So let's say this is pi over 6, this is pi over 3. Opposite of pi over 6 will be 1, opposite of pi over 3 will be root 3 and opposite of right angle will be 2. Okay, so this is one of the special triangles. Now using that, the one with the half sine is opposite over hypotenuse. So from here opposite is root 3, that's not what we want. From here opposite is 1 and hypotenuse is 2. So the reference angle we get here is, we cannot use calculator for this. So we need to know reference angle from that special triangle here is pi over 6. Now that we know it's pi over 6, we know in the first quadrant theta and alpha are same. So one of the answer we have is pi over 6. Now for the second answer, we know theta 2 in the second quadrant is pi subtract alpha. So in our case, pi subtract pi over 6. Taking common denominator, this will be 6 pi over 6 subtract pi over 6, giving us 5 pi over 6. Let's look at the another one. We are given cos theta equals negative 1 over root 2. So again, let's quickly sketch this using CAST rule. Cos negative, all S T C, cos negative in second and third quadrant. So we can say quadrant 2 and quadrant 3. Now to find alpha, again we will draw a special triangle here. Special triangle here. We have 1 over root 2 is the easy one. 1 with pi over 4 and pi over 4. The side lengths are 1, 1 and root 2. So either way, the reference angle for 1 over root 2 here will be pi over 4. Now that we have reference angle, theta 1 in the second quadrant is pi minus alpha. So in our case, pi minus pi over 4 and that will be 3 pi over 4. And the second one will be then pi in the third quadrant, it is pi plus alpha. So that will be pi plus pi over 4. So 1 plus a quarter. So that will be 5 pi over 4. And those two will be our answer for this one. Let's see some more. Let's say we are given cot theta equals negative 1 over root 3. So again, let's quickly sketch this first, in which quadrants this happens. It is cot. So first thing we can write is then tan theta given to us is negative root 3. So tan negative, tan all positive here, sine positive here, tan positive here, cos negative here. So tan negative is in quadrant 2 and quadrant 4. So we'll say quadrant 2, quadrant 4. And then we draw a special triangle with root 3 in it. That's the one with pi over 6 and pi over 3 there. So that will be something like this. Okay. Let's say this is pi over 6. This is pi over 3. Opposite of pi over 6 is 1. Opposite of pi over 3 is root 3 and this is 2. Now we are given tan theta equals root 3. Tan is opposite over adjacent. So from here, opposite is root 3. That's what we want. If we want, we can write this root 3 as root 3 over 1. So opposite over adjacent will be then alpha will be pi over 3. So we will say alpha here is pi over 3. Now depending on the quadrants, we will get our angles. So because we are in the second quadrant, we can say theta 1 equals pi minus alpha. So in our case, pi minus pi over 3, giving us 2 pi over 3. And for the fourth quadrant, it is 2 pi minus alpha, giving us 2 pi, subtract pi over 3, which will be then 5 pi over 3. Because it will be 6 pi over 3 minus 1 pi over 3, which will be 5 pi over 3. Now let's say we are given secant theta equals negative 2 over root 3. So first thing we'll write is reciprocal of secant is cos theta, which will be negative root 3 over 2. Now again sketching this, cos negative, so all positive here, sine positive, so it's negative here, tan positive, so cos is negative there, and cos. So we get answers in quadrants 2 and quadrants 3. Now for finding reference angle, we can use the same triangle as previous one. It's the same triangle because it has root 3 and 2 in it, and cos is adjacent over hypotenuse. So from here, adjacent is 1, hypotenuse is 2, so it's 1 over 2. But that's not what we want, so we have to switch angles. So from this angle, adjacent is root 3, hypotenuse is 2. Notice we are not getting negative because negative is already taken care by which quadrants. So I am just looking for root 3 over 2. We don't care about negative yet. So root 3 over 2 will be then for cos will be from here. Cos pi over 6 will be root 3 over 2. So alpha here will be pi over 6. Now that we have alpha, in the second quadrant we know theta will be pi minus alpha. In our case then pi minus pi over 6, giving us 5 pi over 6. And for theta 2 then, in the third quadrant it is pi plus alpha. So in our case it will be pi plus pi over 6, which will be then 7 pi over 6. And that's how we get two answers here in exact form. Again, we cannot use calculator here to find alpha because if you punch in calculator cos inverse root 3 over 2, it will give you either degree answer if your calculator is in degree mode, or if your calculator is in radian mode, it will give you a decimal number equivalent of pi over 6. That's not what we want. We were asked to find theta in exact form, meaning that no decimal here.